Have you ever been looking for a parking spot down the street and you check one parking spot and there's a car there, and then the next parking spot is also full, and then the next one, and then the next one, and the next one, you just can't find a parking spot? Well, today we're gonna learn a method on how you can go about maybe finding a parking spot a little bit faster. Okay. So let's go over two collision resolution techniques. So we'll start with linear probing. Linear probing is basically whenever you have a collision in a hash map, you look for the next available bucket and you put the new value there. So let's say the output of my hash function was 5. So 5 would go in the 5th spot, but this spot is full. So it goes to the next available bucket. So this is analogous to you driving down this street, turning left on this street, then looking for a parking spot. This one's full, so you park in the next one. Easy peasy. Let's continue with the example. So if the output of your hash function was 6, it would want to go here, but this one's full, and then you check the next one, that one's full, and then you check the next one, and this one's empty, so 6 can go there. Next, let's say you wanted to put in 7. 7 wants to go here, this is full, so it goes to the next available bucket. Okay. So the issue with this method is that it creates clustering. So what is clustering? Clustering is when the buckets of the hash map all are full or have values in them right next to each other. So this creates some issues with hash map time complexities that we'll go over soon. Next, let's go over quadratic probing. So what is quadratic probing? Quadratic probing is, instead of checking for the next available bucket by going meticulously along the hash map until you find it, you check the 2nd bucket, then the 4th bucket, then the 8th bucket, and so on. So let's go with the same example. My hash function output is 5, that wants to go here, and this one's full, so we check the 2nd bucket. 2nd bucket's full, 2 over is full, so then we go 4 over. So we go 1, 2, 3, and then we loop back around, 4. So our 5 goes here. Okay. So what this is analogous to is, let's say you had a car that turned right, or turned left, like the initial example, and it found that this parking spot was full. So instead of just going to the next one or going down the line slowly, driving slowly, checking every single spot, it just hit the gas and went right straight to the 5th spot, and went so fast that it wasn't able to park in any of the other parking spots. Now, this is sometimes better because you just want to guarantee a parking spot, not necessarily, find the best spot for your car, so it's also the same, in computer science. Oh, sorry, not done with the example. Okay, now let's put in 6. So 6 would go here, okay. Then 7 collides with this spot, so we go over 2, and the 7 goes here. So now, as you can see, our hash map has a more spread out value set, so less clustering. And this is better because for greater load factors of hash maps, the search and insert times for the hash map with a quadratic probing method will typically be less than with a linear probing because there's no clustering. So what is this analogous to? So this is like if you had a really big parking lot with very little cars in it. So that's like a small load factor, right? And then you try to find a parking spot. It's pretty easy to find a parking spot using both methods. Doesn't really matter, right? But then you had a really full parking lot, right? And you're either meticulously checking every single parking spot to see if it's full, or you're just, eyeballing it, trying to find the next available parking spot by driving pretty fast. So that's kind of the difference between linear and quadratic probing. That's pretty much it. Have a good day.